Alright, this is our next notes in Algebra 1. It's going to be on transformations. We've been looking at exponential functions, and we've been looking at exponents and radical expressions, and now we're going to kind of move these little exponential functions around. So we kind of know what exponential growth looks like, something that kind of looks like this, okay? And we know that exponential decay kind of goes the other way. It's going down, right? There's a decay one. And we're going to look at now moving these around, okay? And I'm just going to give you the general form here, and we'll just go from there. And tomorrow in class we'll go over some of these exactly in detail how they work. So the general form for an exponential function, I have expo function, that's exponential, is f of x, which could also be y, equals ab times to the power of x minus h plus k. Okay? So here we're saying we're going to do something to the exponent, the power itself, or we're going to add a number to it, we're going to add something to it, or we're going to times it by a certain number here. Okay, so we have a, we're timesing it, h, we're going to do something with the exponent, and k, we're just going to add a number to the whole thing. And also we can add a negative number in front as well. That has to do with a as well. We'll talk about that in just a minute. So that's the kind of general form. And then here's what they do. So a stretches or compresses the original graph. So whatever a is, if it's a number like 3, perhaps it's a fraction, a half, or whatever, or maybe it's a negative. But if it's just a number, we're not worried about the excuse me. If we're not worried about the negative yet, but let's just say the negative's not there, and it's just ab to the power of x minus h. But just a, you can either stretch it or compress it based on whether it's a whole number or a fraction. Okay? And then if it's a negative number, what that's going to do, if there's a negative, some kind of number in front of here, it's going to reflect that across the axis. So if we had a negative, just a negative a for this one, just a negative in front of it, it would just reflect it over that axis like that. Okay? Or this one, if it was reflected, it would kind of look like this. Okay? Just reflecting over that x-axis. And so that's what a does. It stretches or compresses or reflects across the axis if it's negative. Okay, h, right here, doing something to that exponent, will move it right or left depending on whether it's x plus something or it's x minus something. And we'll go over that in class. Okay, so we might have this function down here, and we might have it go this direction, right, or we might have it go left, that direction, based on what h is, positive or negative, whether we're adding a number to x or whether subtracting. That's h. And then k translates up or down. So if we add a number to the original function, we're either going to go, if this was our original right here, just say that's it. We would just move it up or down, down or up. We either go down this way or up that way. Okay, and that's k. And those are really the kind of the basic ways we're going to transform this. We're either going to stretch it or compress it based on what a is. We're going to reflect it across the x-axis. If it's a negative, we're going to move it right or left based on whether we're adding or subtracting from the exponent or the power. And then we're either translating it up or down based on what k is, what we're adding or subtracting to the exponential function, whichever one we have. And here we see a big mess, right? You can see I kind of moved. This is our original. I wish I had a pen here to mark it. But our original is kind of right here, this guy. And we can move it left or right, or we can move it down or up. Okay? So make sure you add that to your notes, and I'll see you in class.